Illinois EPA has been tracking water since about 1972. If you look back to that year, about a third of the water was good, 54% fair, and the rest poor. We jump forward to 2010, some big improvements. We've got about 2/3 of the state that's identified as good. The bad news is that the poor category is largely agricultural impacts, sedimentation, nutrient enrichment. That's the real issue that we're dealing with. The other thing that's going on at the same time is that farmland values have shot through the roof. The average price of farmland in Illinois is $6,000 an acre. That's the average. Champaign County is probably twice that. So a lot of pressure as far as not only environmental but also looking at incomes. The price of corn this last August was almost $7 a bushel. We're historic trends, so we're off the charts as far as what farmers are getting for their crops. So we have to take that into account when we look at what type of practices we want to recommend. The thing that we're looking at in terms of water quality, it has to be both environmental and also economic. The two issues are still erosion and nutrients. The projects I'll talk about today very briefly will be related to nutrients and some of the work that we're doing there. This is the end result. If we have excess nutrients, we have algal growth, we have eutrophication, we have biotic problems for everything that's trying to make a living out there. So this is what we're trying to avoid at the local level, at the watershed level, and ultimately to the Gulf of Mexico. If we look at the big picture here, and you see a lot of dark colored watersheds in Illinois indicating they're nutrient impaired, obviously we're having local impacts, but we're also contributing nutrients to the Gulf and causing hypoxia. And so that's kind of what the focus of a lot of activity is right now. US EPA is recommending a 45% reduction in both nitrogen and phosphorus loading to the Gulf to impact hypoxia. And that's a pretty tall order if we're looking at trying to make a difference. And so the projects we're looking at are gearing towards nitrate primarily. We're trying to act at the tile drainage level, and certainly we want to make this practice applicable, and so we're looking at tile drainage management is the focus. A real quick approach to do that is to plug the tile for part of the year, this drainage water management. We basically back up the water in the field. When the farmer wants to get into the field, we open it up, it drains, and he's able to plant and do his field work. By doing this, by plugging the tiles for part of the year, we see a pretty significant reduction in nitrate loss. Looking at the black line is free drainage, the checkered line is controlled drainage, and you see a pretty substantial reduction in terms of nitrogen loss. So it works. We're trying this on a watershed scale. The project that we have is an integrated watershed project. It involves research, teaching, and outreach in the Salt Fork, and so we're trying to implement this on a widespread scale to see if it can be adopted. The real challenge is to get farmers to do it, though, and so one of the things that we're looking at, we're trying to assess their willingness to adopt this practice. We've done some survey work. We've asked them, will they adopt it? How do they want to get their information? What's the best way to get it implemented? And so the results of the survey, one of the questions we asked is, where do they go for information? What form do they want? They all said that field demonstrations were the preferred mechanism. 71% liked that idea. Web-based information, internet sites, not too popular, and so we had a field demonstration. We set this up. We invited farmers out. We had buses. We took them around. We showed them the sites. We talked about how important it was. They got a chance to look down in the hole and see what a controlled drainage structure looked like. Not a lot to see, but at least they had that experience. The other part of this project involves teaching, and so we helped teach a fields class with the NRES faculty this past summer. We're looking at splashing around the streams. We had colleagues from the Prairie Research Institute talk about macroinvertebrate sampling. We had a lot of people involved, so it was a kind of an integrated approach. The next project I'll talk about real quickly is the same cohort, the same team of folks, but looking at bioreactors in constructed wetlands. It's kind of the next wave. Again, integrated project, research, outreach, education, funded by NIFA. We're looking at trying to do a little bit more, not only stopping the tile lines, but in this case, we're actually diverting some of that tile flow through a bioreactor. It's full of wood chips. The idea is we'll denitrify some of that nitrate and reduce loading to the stream. That's the ultimate goal. The other part of this project that we're looking at involves constructed wetlands. And so we're putting in wetlands. We're looking at new ones. We're also looking at established wetlands that were put in about 17 years ago. The idea to see if they're still functional and try and assess whether or not they're still working. So very quickly, it's going to take a combination of practices. It's going to be watershed scale is probably most appropriate. The recommended practices were going to vary based on individual farm operations, but the most important thing, the critical thing to keep in mind that really is the take-home message of this whole presentation. Oh, shit. Sorry.